exclusively code 1533. Find the index of the larger number. For this question, it gave an array reader, which can, this kind of class have two functions. One is it get the length of an array, and also it have a method called compare sub. This compare sub have 4 parameters. That is from the range left to right and x to y. Compare the sum. And if the L, R, X, Y are all included, so it means if from in this array, if there is L, R, and X, Y, all of the, it calculates the sum of this range. If this one is bigger than this one, then return 1. This one is smaller than this one, then return -1. If it equals, then return 0. So it have two functions. And for this question, it says that the array has only one integer is larger than the rest of the integer. All the others are the same. That's trying to find the index of the larger number. And the thing is that, of course, we can, for example, this the example 1, right? What he do is that the compare 0, 0 to 1, 1, right? 0, 0, that is 7. The sum is 7. This is 7. It is equal, right? Then it iterate to next one until it finds 4, 4, 5, 5, right? This is 10. This is 7. So we know the index 4 is a larger number. But the thing is that it says that we can call compare sub at most 20 times. And for this kind of array, it has a range to be 5 times 10 to the power 5. So what we're thinking about that is we cannot do linear operations. What we do is that we should do some log operations. So what we this reminds us to do this question to be using binary search. So the thing is that so let's write code. We'll have the length of the array first. Reader dot length. So we are binary search those kind of the index which have the large number. So what we have int start equals 0 and equals a-1, right? So what we are going to do is that while start at 1 smaller than end, we'll have int mid equals start plus end. Minus start divided by 2, right? So what we are going to do is that we're trying to see if this kind of range and this kind of range, which one is bigger, right? So we divide that into half. If this one is bigger, that means the large number is on the left. If this one is bigger, then it is on the right. Here are two scenarios. That is this array from start to end. If there are odd number of elements, right? For example, there is on the left there are 2, 1, 2, right? And if it is odd, for example, there are 5 elements, and the mid is just for example, if we are at the index 0 to 4, okay. 0 to 4, and this kind of index is 2, right? This index, okay. So there are 5 elements in it. So if this is odd number, we calculate from 0 to mid and the mid to 4. There are to compare this kind of range. And there are 3 kind of scenarios. Is that if the left greater than right, then we'll search on the left side. If the right is greater than left, we'll search on the right side. If left and right are equal, because this is the odd number, that means the bigger one can only be in the middle. We just return. And the other scenario is that from the left to right, it is an even number. For example, this is 0 to 5, okay? And these two, there are 0, 1, 2, right? There are 3 elements on the left. On the right, we should calculate from, instead from 2 to 5, we should calculate from 3, 4, 5, right? As there have, so there is one element is greater than the others. So if the array that is even number, we can conclude that either the left is greater than right or the right is greater than left. It will not be equal. Otherwise, we cannot find one is greater, right? So we'll consider this kind of problem into 2 scenarios. That is the array is even or it is odd, right? So we'll say if end minus mid equals mid minus start, right? This is the odd number, right? We'll have three scenarios, else that is the even number, right? In this case, we'll have int, we'll have compare, okay? Compare results. Compare. Call compare, okay? Equals reader, but compare subset, right? Compares using this kind of function. We are compare what? Compare from the start to mid and mid to end, right? So in this case, it has 3 kind of scenarios. Let's say if CMD, CMP equals to 1, that means the left is greater, so that will have end equals mid, right? And else if CMP equals -1, we'll say we'll have start equals mid, right? Else we'll have return mid, right? So this is a odd number, and for even number, we are have just if reader reader compare subset start mid and the mid +1 to end, right? So if this one equals 1, that means left is bigger, so that will have end equals mid. Else start equals mid, right? So this is binary search. The things that one thing to take notice that we write the result here to compare the result here instead of someone may write like this, right? Like this. This will double the calculation size, right? So if we, it will if we, for some of the corner case, the test case will not pass because it will have calculate twice. So we calculate outside. It will save one time. Every calculation just half of the calculations, right? So in the end, when we jump out of the while loop, we know the start is just one index bigger than less than the end. So we just return reader start end. If this one equal to 1, right? So that is the start. Else that is return end, right? Reader compare subset. Okay. This will be the n. This is binary search, right? Binary search, so it will be the log n operation.